It has been 45 years since NASA initiated the Voyager 1 spacecraft's journey into the solar system despite being designed for a mere 5-year mission. This remarkable craft continues to traverse uncharted regions of the universe. Recently, however, Voyager 1 has begun transmitting unusual data back to NASA, leaving many of the agency's leading scientists perplexed. Today we will explore some of the strange information being relayed by the Voyager 1 spacecraft. The history of the Voyager program commenced in August 1977, when NASA launched Voyager 2 to explore Jupiter and Saturn before proceeding to Uranus and Neptune. A few days later, its twin Voyager 1 was also launched. Both spacecraft were nearly identical, each weighing about the same as a small automobile. The mission's success hinged on the precise timing of their launches, taking advantage of a unique alignment of the planets that year which allowed for efficient travel from one planet to another without significant course adjustments. To achieve slightly different trajectories, NASA deliberately introduced a 16-day gap between the launches. Consequently, in December 1977, Voyager 1 passed its sibling. Despite its later launch date, from that moment Voyager 1 became one of NASA's most valuable assets for groundbreaking space discoveries. In 1978, Voyager 1 began sending back images of Jupiter to Earth, positioned approximately 265 million km away. A year later, it devoted over 100 hours to capturing nearly 4,000 images of Jupiter, enabling the creation of the first-ever time-lapse showcasing the gas giant's rotation. Shortly thereafter, it became the first spacecraft to identify Jupiter's rings and 2 new moons. Its next destination was Saturn, where it had to adjust its trajectory slightly to avoid a collision with Titan, one of Saturn's largest moons. During its orbit of Saturn, Voyager 1 discovered 4 additional moons and transmitted numerous images of the ringed planet back to NASA. Following this phase, NASA decided to conclude the Voyager 1 mission, allowing Voyager 2 to continue towards the ice giants of Uranus and Neptune, thereby becoming the first spacecraft to visit them. Meanwhile, Voyager 1 embarked on its journey toward the outer solar system. The Voyager Interstellar mission officially commenced in 1990, when Voyager 1 was approximately billion km from the Sun. It sent back breathtaking images of various planets, capturing the first family portrait of the solar system. By this time, the spacecraft had taken over 67,000 images, prompting NASA to conclude its need for Voyager 1's cameras. Consequently, the cameras were turned off in 1998 to conserve energy at a distance of 10.3 billion km from the Sun. Voyager 1 surpassed the Pioneer 10 spacecraft launched in 1972, becoming the farthest human-made object from Earth. It continued to widen the gap as it moved into interstellar space. Although its cameras were no longer operational, NASA retained several instruments to communicate with the spacecraft. Voyager 1 successfully exited the solar system and entered interstellar space in 2012, although NASA did not publicly announce this achievement until 2013. At that point, it was moving away from the Sun at a speed of 61.7 kmph. Its sister spacecraft, Voyager 2, would not leave the solar system until 2018. By then, Voyager 1 was approximately 14.5 billion km from the Sun, continuously transmitting signals back to NASA, providing insights about the solar system and beyond. However, Voyager 1 has recently begun to lose some of its orientation, sending back perplexing signals that even some of the world's top scientists find difficult to decipher. It appears the spacecraft itself may be unsure of its exact location. Voyager 1 is programmed to send an alert to NASA if it ever becomes lost in space, and it remains capable of doing so despite the baffling signals. This alarm has not yet been triggered. Furthermore, Voyager 1's antenna appears to be functioning well, allowing regular communication with NASA. However, the agency has grown increasingly skeptical about the reliability of the data being transmitted from the antenna. Presently, Voyager 1 is still capable of receiving commands from Earth and executing them in interstellar space. Given that the spacecraft was designed in the 1970s, its longevity underscores the remarkable reach of NASA's technology. Despite the anomalies, NASA believes that the signals from Voyager may first not accurately reflect the actual conditions on board. So what is occurring within the spacecraft? NASA has equipped all of its spacecraft with specially designed gold-plated discs containing unique audio and video messages intended for potential encounters with extraterrestrial beings. This disc includes over 35 distinctive sounds from Earth, images depicting daily life, over an hour of Western pop music, and greetings from various former U.S. presidents translated into 55 different languages to enhance the likelihood of comprehension by aliens. However, as of 2022, NASA scientists have dismissed theories suggesting that the spacecraft might be under extraterrestrial control. Voyager 1 is equipped with numerous safety protocols designed to activate in case of danger, yet none have been triggered to date. The antenna remains directed toward Earth, which adds to the mystery surrounding the strange signals being transmitted. It has never sent such indecipherable signals before, even under similar conditions. Why is this happening now so far from Earth? According to NASA's project manager for the Voyager mission, these occurrences are generally expected for spacecraft as old as Voyager 1, which has spent over 45 years in space and now resides at a record distance of 23.6 billion kilometers, or around 157.5 astronomical units from the Sun. As the spacecraft travels farther, communication reliability diminishes. Additionally, there is no feasible way to repair Voyager 1 if issues arise, as NASA lacks the capability to dispatch a spacecraft into interstellar space for a rescue mission. Furthermore, two-way communication has slowed significantly, with messages taking an average of 21 hours to travel from NASA's communication stations to Voyager 1. This delay increases the risk of collisions and accidents, potentially hampering NASA's ability to communicate effectively during emergencies. Nonetheless, NASA remains optimistic that it will resolve the current challenges faced by Voyager 1, expecting the spacecraft to continue relaying information about interstellar space. The sheer distance of Voyager 1 makes its communications, though delayed and unreliable, immensely valuable for NASA. At present, NASA is utilizing the spacecraft to test the limits of its past and present technology, with the data proving invaluable for future space missions. However, the time will come when Voyager 1 will no longer be able to communicate with Earth. With each passing day, the likelihood of an accident abruptly terminating the mission increases. Thus far, it has outlived all expectations. As Voyager 1 continues its solitary voyage through the depths of interstellar space, it stands as a testament to human ingenuity and exploration, while also serving as a profound scientific instrument that consistently challenges our understanding of the universe. Launched over 4 decades ago, this resilient probe has far surpassed its original mission goals and continues to provide priceless data. Even as intriguing mysteries arise, one of the most extraordinary aspects of Voyager 1's mission is its longevity. Designed and constructed in the 1970s, the spacecraft is equipped with technology far less advanced than today's standards, yet it has endured the harsh conditions of space, withstanding cosmic rays' extreme temperatures and the vast emptiness beyond our solar system's edge. Its durable construction and robust systems have enabled it to exceed expectations, continuing to transmit data back to Earth even from over 23 billion kilometers away. The scientific insights provided by Voyager 1 have been groundbreaking, ranging from detailed images of Jupiter's tumultuous atmosphere to the discovery of intricate ring structures around Saturn. These findings have not only fueled scientific curiosity but have also inspired future generations of space explorers and researchers. One of Voyager 1's most celebrated achievements is its entry into interstellar space, marking the first time a human-made object has ventured beyond the Sun's influence. This historic milestone, officially confirmed by NASA in 2013, ushered in a new era of exploration, one where our reach extends beyond the confines of our solar system. Voyager 1 continues to send data from this remote region, offering glimpses into the conditions and environment of interstellar space. Although its instruments are aging, they remain operational, collecting data on magnetic fields, cosmic rays, and plasma densities within the interstellar medium. Each transmission provides valuable insights into the dynamics of the galaxy and aid scientists in refining their models of star and planetary system interactions over vast distances. However, recent developments have raised intriguing questions about Voyager 1's condition and the nature of the signals it is sending back to Earth. NASA scientists have noted anomalies in the received data, including unexpected fluctuations in signal strength and sporadic bursts of indecipherable noise. These anomalies have sparked speculation and debate within the scientific community, leading to various theories about the nature of Voyager 1's current state and the data it transmits.